Alright guys, this is our test review for systems of equations with three variables. On the first two questions, they gave you solutions and asked you whether or not this ordered triple is a solution to the system, and all they were asking you to do, guys, is plug in those numbers, okay? So I'm going to plug them into each equation and see if they work. So for the first problem, this is 2 times 1 minus 3 times 1 plus 1 is equal to 0. I plugged the first one in for x, the second one in for y, and the third one in for z. When I do the math on this, this is 2 minus 3 plus 1. 2 minus 3 is negative 1 plus 1 is in fact 0. So that solution works for this equation right here. We have to check it in the other two equations as well to make sure it works for both of them. So I'm going to plug it into the second. So 2 times 1 minus 1 plus 2 times 1 equals 3. So again, x, y, z. That is 2 minus 1 plus 2. 2 minus 1 is 1 plus 2 is 3. So that works for the second equation. It checks out and it works. I'm going to try the third equation. So it's x plus y plus z is equal to 3, and that is in fact true. 1 plus 1 plus 1 equals 3. And so it checks out for this equation as well, which means that yes, that ordered triple right there is a solution to this system. Same thing here. They want us to plug these numbers in and see if they work in each of these equations. So I'll start with the first equation. So 2 times 1 minus 0 plus 4 is equal to 4. And remember again that this one is x, the 0 is y, and the 2 is z. So this is 2 minus 0 plus 4 is equal to 4. That is 6 equals 4. Is that true? No, it is not. It is false. And if it is false, that means that that solution does not work for that equation. That means it does not work for this system at all. So is this ordered triple a solution to this system? The answer is no. No, it is not. All right, we're going to move on to number 3, where we're going to solve this system. Now I'm going to solve these systems using elimination. So I'm going to pick two equations and eliminate one of the variables. I'm going to start with the second two equations, and I'm going to eliminate y. So I'll rewrite them. X plus y minus 2z is equal to 6, and x minus y plus z is equal to negative 2. I chose y because if you look at these two y's, all I have to do is add these two equations together and we get rid of the y. So I'm going to do that. Add them together, you get 2x plus 0y minus z, so negative 2z plus z is minus 1z is equal to 4. And that's just 2x minus z is equal to 4. So that's one of my two variable equations right there. I need a second equation so that I can figure out what the rest of the solutions are. So I come back over here and I pick a second set. I've got a negative y here and a positive y there. I'm going to use the first and the second just because this is negative and that's positive, so I don't have to multiply by any negatives. So again, I'm going to rewrite the equation. So this is x minus 2y plus z is equal to negative 3, and x plus y minus 2z is equal to 6. I want to eliminate y, so I'm going to multiply the second equation by 2. I'm going to rewrite this entire thing so that I can follow my steps, right, in case I make a mistake. So this is x minus 2y plus z is equal to negative 3, and 2x plus 2y minus 4z is equal to 12. I add those two equations together, and here you see the y's are going to cancel out, so I get 3x plus 0y minus 3z is equal to 9, or just 3x minus 3z is equal to 9. And so now I have this equation here that has an x and a z in it, and this equation here that has an x and a z in it. And so what I can do is I can use those two equations and eliminate one more variable. So 2x minus z is equal to 4, and 3x minus 3z is equal to 9. I'm going to eliminate the z just because it only requires doing multiplication once. Now these are both negative, so I need to change the sign on one of them. And since I have to multiply the top equation by 3, I'll just multiply by a negative 3. So I'm going to rewrite that set so that I can follow my steps. This is negative 6x plus 3z is equal to negative 12. And then 3x minus 3z is equal to 9. And I add these two equations together. And when we do that, we end up with negative 3x plus 0z is equal to negative 3. So just negative 3x is equal to negative 3. We can solve this equation by x. We divide by negative 3. We get x is equal to 1. And that's one of our answers right there. And what I do is I bring this answer back over here and I use it in one of my two variable equations. I'll use it in this one just because there's less math to do. And so I know x is equal to 1. And so that means that this equation becomes 2 times 1 minus z is equal to 4. So that's 2 minus z is equal to 4. Subtract 2 from both sides. Negative z is equal to 2. Divide by negative 1. And you get z is equal to negative 2. And so that's my second solution to this three variable system. Now what we need to do is we need to find y, and the way we find y is by using one of our original equations and solving for y. I'm going to use the second one just because I like that y is positive here. So this is x plus y minus 2z is equal to 6, and I know that x is 1 and z is negative 2. So this is 1 plus y minus 2 times negative 2 is equal to 6. So 1 plus y plus 4 is equal to 6. I combine the 1 and the 4, and we get y plus 5 is equal to 6. Subtract 5, we get y equals 1. And so that's my third solution. And remember that the way we write solutions to these systems is we write an ordered triple, right? And so that's x, y, and z. So it's 1, comma, 1, comma, negative 2. And that's my solution. All right, we're going to look at question 4. We're going to solve this one the same way. I'm going to use elimination with this as well. Looking at this system, well, I know I'm going to use the first equation just because it is the one with only ones. And so I'll use the first equation and the second equation, and I'm going to eliminate z. And so here is my first set is x plus y minus z is equal to negative 9. And then 2x minus 3y plus 2z is equal to 13. Multiply this top equation. I want to eliminate the z's. So I'm going to multiply the top equation by 2 so that I have a negative 2z. Rewrite the whole system. So this is 2x plus 2y minus 2z is equal to negative 18. And then 2x minus 3y plus 2z is equal to 13. Add these two together. This becomes 4x, a positive 2y and a negative 3y is negative 1y, and then plus 0z is equal to negative 18, and positive 13 is negative 5. So you've got 4x minus y is equal to negative 5. That's one of my two variable equations. All right, I need to use another set of equations to eliminate z as well. So actually, I'm going to go ahead and use the second and third. So this is 2x minus 3y plus 2z is equal to 13. And then 3x minus 5y minus 6z is equal to negative 15. And I'm eliminating z, so I need to make this into a positive 6z. It's a 2z, and it doesn't look very much like a 2. It's a 2z. So I can make it into a 6z by multiplying both equations by 3. Or not both equations, I'm sorry, the top equation, all of these terms by 3. And so this becomes 6x minus 9y plus 6z is equal to 39. Now the bottom equation stays the same. It's 3x minus 5y minus 6z is equal to negative 15. And so we can add these two equations together. And when we do that, we get 9x minus 14y plus 0z is equal to, this is 24. This is 9x minus 14y is equal to 24. And what I want to do now is I want to use these two equations to find one of those variables, eliminate one of the variables. So I'm going to do that over here because we're running out of room. So I've got 4x minus y is equal to negative 5, and 9x minus 14y is equal to 24. I think the easiest thing to do is going to just be to multiply this top equation by negative 14. That'll give us a positive 14y. So when we do that, we get negative 56x plus 14y is equal to positive 70. And then 9x minus 14y is equal to 24. Add those two together. And 56 minus 9 is negative 47x. These y's cancel out, so it's plus 0y is equal to 94. And negative 47x is equal to 94. As ugly as that looks, that's nice and divisible. Negative 47. Divide 94 by negative 47, and you get x is equal to negative 2. That works out nicely. So it's one of my three solutions. So I need to find the other solutions. I'm going to bring that x value to this equation right here. And then we'll plug it in. So this is 4 times negative 2 minus y is equal to negative 5. So this is negative 8 minus y is equal to negative 5. Add the 8. And you get negative y is equal to 3. You got to divide by negative 1. And bring it right over here, guys. And when we do that, we get y is equal to negative 3. So that's my second solution to this system. And then what we need to do is take these two variables and plug them into one of the equations to come up with a third variable. It doesn't matter, but we'll just use the first equation. So it's x plus y minus z is equal to negative 9. I know that x is negative 2 and y is negative 3. So that's negative 2 minus 3 minus z is equal to negative 9. Negative 2 minus 3 is negative 5. And then you add 5 to both sides. We'll bring that over here, guys. Sorry, we're running out of space. and you get negative z is equal to negative 4. Divide by negative 1. You get z is equal to 4. And so that's our third solution. And so the solution to this system, remember it's an ordered triple, is negative 2, negative 3, and 4. All right, guys. We're going to look at the second page. Where we are going to solve 2 more systems using elimination because it is so much fun. And then we will we'll look at that word problem down at the bottom afterwards. Okay, the way we solve these systems, guys, again, is that we pick 2 equations and we eliminate one of the variables. For this system, I'm going to pick the last 2 equations because they will allow me to eliminate y by just adding together. Negative y and positive y are going to cancel right out. So I have x minus y plus z is equal to 5, and 3x plus y plus 2z is equal to 4. And I'm going to add these 2 equations together. And when I do that, I get 4x plus 0y plus 3z is equal to 9, or 4x plus 3z is equal to 9. I need to pick a second set of equations to eliminate one of the variables, and so I'm going to choose the top equation and the bottom equation. And so that's 2x minus 2y plus 2z is equal to 9. And then the 3x plus y plus 2z is equal to 4. And in order for me to cancel out one of these variables, and I want to cancel out the y, I need to multiply this equation by 2. So I get 2x minus 2y plus 2z is equal to 9, and 6x plus 2y plus 4z is equal to 8. I almost wrote a 4. It's really important to remember to multiply that last number, all right? And so this is 8x plus 0y plus 6z is equal to 17. So 8x plus 6z is equal to 17. And now what I'm going to do is I'm going to take these two variable equations and I'm going to make a third system out of them. So that's 4x plus 3z is equal to 9, and 8x plus 6z is equal to 17. In order for me to cancel out one of those variables, let's just look at the x's. I need to multiply this top equation by negative 2. If I want to cancel out the x's, I need to multiply the top equation by negative 2. So I get negative 8x minus 6z is equal to negative 18. And then 8x plus 6z is equal to 17. And I add them together. What happens when we do this, oh no, is I get 0x plus 0z is equal to negative 1, which is just 0 is equal to negative 1. Oh no, is that true or false? It is false. And what does it mean when we have everything cancel out and we get a false statement? It means that there is no solution. There's no solution. And so we're done, we walk away. Now you have to show me the work that supports your no solution, guys. You can't just write no solution on the test and leave everything blank. You're not going to get any credit for that. You've got to write out the work that supports the no solution. And when I see your no solution answer on the test, what I'm looking for is a false statement at the end of your work. All right, we're going to try the same thing with this set. We're going to use elimination. And so I'm going to use the first and the second equations to eliminate z, because that's going to go very nicely. And so this is x plus y plus z is equal to 3, and x plus y minus z is equal to 3. And I add the two together, and I get 2x plus 2y plus 0z is equal to 6. So just 2x plus 2y is equal to 6. And then I pick another set to eliminate z. I'm going to use the second and the third. So that's x plus y minus z is equal to 3. And 3x plus 3y plus z is equal to 9. We're going to add them together. So we get 4x plus 4y plus 0z is equal to 12. And that's 4x plus 4y is equal to 12. And what we do with those two equations right there, that's two variable equations, is I stack them on top of each other and use elimination one more time. I'm going to do that over here just to not get us mixed up in the work from problem 5. So this is 2x plus 2y is equal to 6, and 4x plus 4y is equal to 12. If I want to eliminate, let's say x, let's eliminate x, we've got to multiply the top equation by negative 2. It's negative 4x minus 4y is equal to negative 12, and 4x plus 4y is equal to positive 12. And uh-oh, what happens here? What happens is everything over here cancels out, which is 0. And then the negative 12 and positive 12 cancel out, which is also a 0. And that, guys, 0 equals 0 is a true statement. That's a true statement. And if you end up with a true statement, everything cancels out and you get a true statement, then your answer is infinite solutions. Solutions. I can spell, y'all. Hold on. I just got so excited about our infinite solutions. There we go. Now, if you prefer to write out the word infinite, it only has eyes, guys. All right, I told you guys to omit problem 7. If you work it out on your own, way to go. And I'll have the answer for you tomorrow. And so if you've got it worked out on your own and have the right answer, then there will be some bonus points in there for you. All right, let's look at this movie theater. Movie theater charges different rates for attendees depending on their age. Children aged 12 and under are $4, adults are $6, and senior citizens are over 65 are $5. A group of 14 people from a family decides to go to the movies one weekend. There are an equal number of senior citizens as children and 12 and under. The total cost was $66. How many people in the group are in each category? So they have given us in this paragraph three relationships. So we need to assign variables. We're talking about children 12 and under, adults, and senior citizens. And we're not just talking about children, adults, and senior citizens. We're talking about the number of each. So I'm going to say C equals the number of kids. That A equals the number of adults. And that S equals the number of senior citizens. Okay, and so what we do is we use those three variables to write three relationships. There is a statement of cost. So this 4, adults are 6, so the children are 4, adults are 6, and senior citizens are 5. And it doesn't state right after this how much it costs total, but there is this money statement right here. And so what we know about this is that the total cost of the tickets was $66. And if you've been to the movies, you know that what you can do is you can multiply the cost of the ticket by the number of people going, right? If movie tickets are $10 and you got 5 people going, that's $50. Well, since the costs are different, we have to work with our variables. So $4 for each child plus $6 for each adult plus $5 for each senior citizen is going to equal $66. And that's our first relationship. They said a group of 14 people from a family decides to go to the movies. So a group of 14 people, that's our second relationship. We know that the children plus the adults plus the senior citizens is 14. The number of kids plus the number of the adults plus the number of senior citizens is 14. And then the last thing they tell us is that there is an equal number of senior citizens as children. And so there's an equal number of senior citizens and children. So that means the number of senior citizens and children are equal to each other. S is equal to C. And what you can do with this, guys, is you can take these two equations and you can make them each into a two-variable equation. So what I'm going to do is I'm going to plug in S instead of the C's. So I know that the number of C's and the number of S's are the same. And that makes this equation right here, because S equals C, that makes this equation right here 4S plus 6A plus 5S equal to 66. And so I plugged in, instead of C, I put in an S. That's that equation. And this equation, because S equals C, becomes S plus A plus S equals 14. And so what I did is I took out the C's and I put in S's instead, because I know that there are the same number of children and senior citizens. So it's a stated relationship. Now what I have is two variable equations. So 4S and 5S, that is 9S plus 6A is equal to 66. And then I've got 2S plus A is equal to 14. And now I have a two-variable system, and I can eliminate one of the variables. I can do that by multiplying the second equation by -6. So this is 9S plus 6A equals 66. And then my second equation becomes -12S minus 6A is equal to -84. And you can add those two equations together. When you do that, you get -3S. The A's cancel out, and we get is equal to, this is -18. I'm going to bring that over here. -3S is equal to -18. Right. Over here, like that. Divide both sides by -3, and you get S is equal to 6. And so I now know that there were 6 senior citizens. And because I know that the number of senior citizens and the number of children are the same, I know that there were 6 kids, right? And guys, this is a simple enough problem that if you have shown me this math to get here, I will take that you can add 6 senior citizens and 6 kids to get 14. So that means that's 2 adults. Okay. And we would have gotten that by saying 6 children plus the adults plus 6 senior citizens is equal to 14. And right, that's 12 plus A equals 14. Subtract 12. So A is 2. But if you can show me all of this work to get to the S equals 6, then I will believe you that you can do that little bit of mental math in your head. Okay? All right, guys, so there is your test review. Use it wisely. I look forward to seeing you all in class tomorrow, bright-eyed and bushy-tailed and ready to take this 3-variable test and ace it.